You're driving down a busy street when suddenly, out of nowhere, a car runs a red light heading straight for you. In that split second, what if your car already knew what was coming? What if it started protecting you before the impact even happened? Sounds like science fiction, right? Well, buckle up, because Tesla's about to make that fiction a reality with the Model 2. And honestly, after diving deep into what this car can do, I'm convinced we're witnessing something that'll change driving forever. Let me start with something that blew my mind. We all know airbags, right? They've been around for decades, saving countless lives. But here's the thing, they've always been reactive. Someone hits you, sensors detect it, airbags deploy. Simple, effective, but also limited. Now imagine if your car could see the accident coming and start inflating those airbags milliseconds before impact. Not after, before. That tiny difference, those precious milliseconds, could mean the difference between walking away with minor bruises or spending months in recovery. And that's exactly what the Model 2 brings to the table in 2026. Here's how it works, and trust me, it's fascinating. The car uses something called predictive airbag deployment. Instead of just relying on crash sensors that react to impact, the Model 2 uses cameras to constantly watch what's happening around you. Think of it as having an incredibly alert co-pilot who never blinks, never gets distracted, and processes information faster than any human ever could. These cameras feed data to the car's brain, which has been trained on hundreds of real-world accidents. It's learned to recognize patterns, to spot that exact moment when a collision becomes unavoidable. So what happens when danger appears? The system doesn't panic and it doesn't hesitate. It calculates. Within microseconds, it knows if that car swerving into your lane is going to hit you. It knows if that pedestrian stepping into the road means you'll need to brake hard. And when it determines impact is coming, it starts preparing. The airbags begin inflating just a few milliseconds early. Now, you might be thinking, a few milliseconds? That's nothing. But let me put this in perspective. A typical airbag needs to deploy in about 20 to 30 milliseconds after detecting impact. A single blink of your eye takes 300 milliseconds. We're talking about decisions made in time frames your brain can't even comprehend. And in those impossibly brief moments, the difference between life and death is measured. The beauty of this system is that it doesn't replace traditional safety features. It enhances them. The cameras work alongside impact sensors, creating layers of protection. If one system misses something, the other catches it. It's like having both a smoke detector and a heat sensor in your house instead of just one. This redundancy means fewer mistakes and faster response times than we've ever seen in a mass market vehicle. But wait, there's more to this story. This breakthrough didn't just happen in a lab with engineers making educated guesses. The development team did something pretty remarkable. They analyzed real crash footage from thousands of vehicles, studying exactly what happens in those terrifying moments before impact. They looked at behavior patterns, at how collisions unfold, at the physics of cars crashing into each other. Then they fed all that data into machine learning algorithms, teaching the system to recognize danger with incredible accuracy. It's almost eerie when you think about it. The car learned from tragedies to prevent future ones. Every accident made it smarter, more capable of protecting the next driver. For you and me, sitting in the driver's seat, the experience will feel seamless. You won't notice the system working until that one crucial moment when it matters most. And when that moment comes, instead of the airbag smashing into you at full force, it'll already be partially inflated, forming the perfect cushion right when your body moves forward. The result? Smoother, more effective protection. Less trauma to your head and chest. Better outcomes when seconds count. This shift represents something bigger than just clever engineering. It's a fundamental change in how we think about car safety. For decades, safety meant building stronger cages, thicker steel, bigger crumple zones. All important stuff. But now we're moving into an era where intelligence matters as much as metal. Where software saves lives just like seatbelts and airbags do. And honestly, that's pretty incredible when you stop to consider it. Now, let's talk about something that might seem trivial until you're in a burning car. Door handles. Seriously, stay with me here. You know how sometimes the simplest things become impossibly complicated in emergencies? Opening a car door is supposed to be automatic, something you do without thinking. But what happens when the power cuts out? What happens when you're panicked? Smoke is filling the cabin, and you can't remember which hidden lever to pull or what special procedure to follow. This actually happened with some earlier models. Parents couldn't get their kids out of hot cars because the electronic systems failed, and they didn't know about the manual release hidden somewhere in the door panel. Can you imagine that terror? Your child is in danger, and you can't figure out how to open a door. It's the kind of design flaw that keeps engineers awake at night, and rightfully so. The Model 2 takes a completely different approach. One button. That's it. Whether the car has power or not, whether you're calm or panicking, whether you're 8 years old or 80, you press the same button and the door opens. With power, it activates the electronic motor. Without power, it mechanically releases a latch. No hidden levers, no confusing backup systems, no need to remember special instructions. Just muscle memory doing what it does best. Think about how smart this is from a human psychology standpoint. In an emergency, your brain basically shuts down higher reasoning. You're running on instinct and trained responses. If you've opened that door 1,000 times the exact same way, your body knows what to do even when your mind is screaming in panic. This single gesture approach means anyone can escape quickly, regardless of age, strength, or mental state. It's democratic design at its finest. The exterior handles follow the same philosophy. They are slightly recessed for aerodynamics, sure, but they are shaped in a way that practically begs you to pull them. No fancy sensors needed. No waiting for the car to recognize your presence. Just grab and pull, and it works. Always. Even if every electrical system in the car is dead, that handle will function because it's mechanically connected to the latch. It's almost like going back to basics, except these basics are wrapped in cutting-edge engineering that makes them lighter, stronger, and more precise than old-school designs ever were. Creating this unified system required completely rethinking how car doors work. The engineering team had to merge electrical and mechanical pathways into one cohesive unit. Everything had to play nice together. The handle, the latch mechanism, the sensors that detect whether you're using electronic or manual release. It's one of those invisible achievements that nobody notices until something goes wrong. And with the Model 2, nothing goes wrong because the system is elegant in its simplicity. Here's something that really impressed me. The simplified design doesn't compromise structural integrity one bit. The doors still pass brutal safety tests that require them to withstand massive forces from multiple angles. So you get the best of both worlds, easy operation and rock-solid protection. That's rare in engineering. Usually, you make a trade-off. Make something easier to use. It gets weaker. Make it stronger. It gets more complicated. But somehow, they manage to improve both. This design philosophy reveals something important about how modern cars should be built. It's not enough to ace crash tests if real people can't use the safety features effectively when it counts. The Model 2 doesn't just install better equipment. It teaches better habits. It prepares drivers for the worst scenarios. It creates what I call emotional accessibility, the feeling that you can handle whatever comes your way because your car isn't fighting against you. Speaking of protection, let's dive into what happens when something slams into the side of your car. Side impact are particularly nasty because there's so little space between the door and your body. Just inches separate you from whatever's hitting the vehicle. Most cars try to solve this with thick doors and strong beams, which helps but only goes so far. The Model 2 takes a more sophisticated approach, directing energy away from you through a carefully choreographed sequence. First, there's an intrusion beam inside the door itself. This isn't trying to stop the impact. That would be impossible. Instead, it redirects a force downward to the reinforced side floor. Think of it like martial arts. You don't meet force with force. You guide it where you want it to go. The side floor is built tough enough to absorb that initial energy spike, but it's also designed to deform in a controlled way. This prevents the door from caving inward violently, which would obviously be catastrophic for anyone sitting there. Next, the impact energy hits the outer edge of the battery pack. Now, you might worry about that, but here's the clever part. That section acts like a secondary beam running the length of the car. Instead of the force concentrating at one point, it spreads out along a line. This distributes the load, protecting both the battery cells and keeping the floor more stable. Between the battery pack and the floor are special absorption inserts that act like cushions, stretching out the impact over slightly more time. This creates space, Literally, 4 side airbags to deploy correctly and do their job without interference. Finally, cross members under the floor transfer remaining energy to the opposite side of the car. It's like an invisible shock absorber working at speeds you can't perceive. This prevents any single point from taking too much punishment and helps keep the cabin shape intact. Your seat, your seatbelt, the mounting points, they all stay where they should be. The result isn't just about surviving the crash. It's about what happens after. With less deformation, repairs become dramatically simpler and cheaper. Body shops don't need to straighten entire sections of chassis or replace massive components. They handle localized damage, and you're back on the road faster. It's a cascading benefit that helps everyone. You save money, insurance costs stay lower, and you don't lose your car for months. What strikes me most about this layered protection is how it changes your relationship with the car. Knowing that engineers spent countless hours figuring out exactly how to redirect forces away from your body, even by millimeters, creates genuine peace of mind. The car becomes more than transportation. It becomes a guardian that's always paying attention, always ready to do its job when needed. And remarkably, all this protection doesn't turn the Model 2 into a lumbering tank. It stays compact, nimble, and efficient. That's the magic of smart engineering, getting more safety without more weight, without higher costs, without sacrificing the things that make a car enjoyable to drive daily. Now let's get into something most people never think about, how the body panels are actually held together. Traditional cars use spot welds, little points of melted metal joining panels. It works fine, but it concentrates stress at specific locations, which can lead to squeaks, rattles, and eventual wear. The Model 2 uses something called rivet bonding, combining structural adhesive with self-piercing rivets. Yes, this sounds like aerospace technology because it basically is. Here's the process. Adhesive gets applied as a continuous bead between panels, creating a wide contact surface that spreads stress evenly. Then rivets punch through, locking everything in place without drilling holes that weaken the metal. The combination is brilliant. The adhesive distributes forces smoothly while the rivets provide precise mechanical strength. Together, they create a body that's more unified, more rigid, and significantly quieter than traditional construction. This approach also solves a tricky problem with mixed materials. The Model 2 uses ultra-high-strength steel where protection is critical and aluminum where weight savings matter. But steel and aluminum don't play nice together. They cause galvanic corrosion when they touch, slowly eating away at the connection. The adhesive layer acts as an insulator, preventing this chemical reaction while also sealing out water and dust. Your car ages better and resists the elements more effectively. The tactile difference is immediately noticeable. Close the door on a Model 2 and it sounds different, feels different. There's a solidity to it, like sealing a vault. This isn't just for show. It comes from well-distributed rigidity and better seals throughout the structure. The same principle applies to the roof, the pillars, everywhere panels meet. Less twisting means less noise when you drive over bumps or rough roads. For anyone who spends serious time commuting or traveling, this acoustic comfort becomes a subtle luxury you didn't know you needed. Repair advantages continue here too. Because self-piercing rivets don't require heat like welding, panels don't warp during assembly or repair. If you have a minor collision, a technician can drill out the damaged rivets, apply fresh adhesive, and install new rivets in the exact same spots. No heating, no hammering, no wrestling with misaligned structures. The repair is cleaner, faster, and more predictable. Most importantly, it costs less. This attention to long-term usability shows a maturity in design philosophy. It's not enough to build something impressive that deteriorates within a few years. The Model 2 is engineered to remain enjoyable, maintainable, and reliable for the entire time you own it. Even the type of glue matters in this plan. That level of thoroughness is rare in any vehicle, let alone one position as affordable transportation. Everything we've discussed so far builds toward a simple but powerful conclusion. The Model 2 represents a new kind of thinking in car design. It's not about cramming in the most features or bragging about the biggest numbers. It's about integration, about systems working together intelligently to create something greater than the sum of its parts. It's about protecting people before disaster strikes, making sure they can escape when needed, absorbing impacts efficiently, and staying dependable year after year. What really gets me excited is that this technology isn't reserved for luxury models. This is the affordable option, and yet it's packed with engineering that would make premium brands jealous. That democratization of safety and quality, making advanced protection available to more people, feels genuinely important. It signals a shift in priorities across the entire industry. So here we are in 2026, watching a car that quite literally sees a future take shape before our eyes. Those few milliseconds of predictive action, that single button that always works, those carefully choreographed layers of protection, they all add up to something meaningful. They represent progress in the truest sense, making life safer, easier, and more reliable for everyone. If you found this deep dive into the Model 2's engineering as fascinating as I did, make sure you hit that like button and subscribe for more content breaking down the technology that's shaping our future. Because trust me, this is just the beginning. The innovations happening right now are going to redefine what we expect from our vehicles, and I'll be here to walk through every breakthrough with you. Until next time, drive safe and stay curious.